All right, in this video, we are going to solve equations that involve logs and exponential objects. Okay, this is going to be the last lesson in our exponential and log unit, and I think y'all should be pretty good at this because we're really not asking for too crazy of equations here. All right, and kind of the first thing I want to point out is that if two things are equal, then we can take both of them, take e to both of their powers, and that will still be equal. And if two things are both equal, then we can take the natural log of both of them, and it will still be equal. And this is true for bases other than e. Just wanted to point it out. Probably the easiest to think of in terms of e. And then I'm also going to write down a couple of these properties that are going to be really useful to us as we go to solve equations. Okay, so if we have, bless you, log with base b of b to the x, those things, y'all would say they cancel each other out. I wouldn't probably use that language, but, you know, it's pretty much what happens, okay? Because you're saying, well, kind of this log here is saying, what exponent do I put on b to get b to the x? Well, I put the x exponent on b to get b to the x. Okay, so this is one of them that we definitely need to know for today. And then the kind of the opposite property would be b to the log base b of x is also going to be equal to x. And again, these kind of undo each other, is what y'all would say. And again, if you think about, okay, just this log here that I'm highlighting, that is the special exponent that I put on b to get x. Well, I'm going to put that special exponent on b, and I'm going to get x. Okay, that's basically what that's saying. And this is basically the technique that we're going to use to solve all of these equations. All right, so the first examples we've got are kind of some things with base 2. We've got 2 to the x equals 9.5, and log base 2 of x is equal to 10. So we need to do the same thing to both sides of the equation. Okay, that's always something that's been true in every algebra course you've taken. We want to do the same thing to both sides, to be fair, right? So what I'm going to do is I'm going to take the log with base 2 of both sides. Okay, so I'm going to do that. I'm going to take the log base 2 of 2 to the x is equal to the log with base 2 and argument 9.5. Okay. Well, now I know that log base 2 of something and 2 to something are opposites of each other, and they kind of cancel each other out like that. I don't really like crossing through it like that, but I know that that's what y'all are going to do anyway, so might as well kind of just do it now. And so this is going to be x is equal to the log with base 2 and argument 9.5. Okay. So this is what we would call an exact answer. On the quiz next time, it's going to ask for exact and approximate answers. So you need to be able to get both and understand what they are. Okay, the exact answer is going to be in terms of a log or something. But the approximate answer is what we're going to get when we use the calculator. So I'm going to kind of bring in the scientific calculator over here. And I'm going to actually calculate log base 2 of 9.5. Remember that we do that by setting up a fraction bar. And we can do either the base 10 log or the natural log. It doesn't really matter. 9.5 divided by same type of log of the base. We're going to get 3.2479. And this value is what we're going to call an approximate solution. Okay. So there will be a blank on each question to say, here's the place where you put your exact answer, and here's the place where you put your approximate answer. Now, not all of these things need an approximate answer. Like this next one over here isn't going to require that. Okay, what we're going to need to do on this one is basically do the opposite of take the log with base 2, and that would be take 2 to both sides power. All right? So that means that 2 to the log with base 2 and argument x is equal to 2 to the 10. But again, I know that 2 to the x and log base 2 of x are kind of opposites, and they kind of cancel each other out. So I get x equals 2 to the 10. Okay. And that is, you can go into the calculator and type that in, and you'll find that that's 1,024. Okay. So it's like, okay, the exact and the approximate solution, there's no decimal, so there's not really any difference. That's not one where I would ask for an exact value, or even make any mention of the difference between the two. Next, I've got some with base e. Okay, it's not going to really be that much different. This first one, if I've got e to the x equals 10, and I want to get that x out of the exponent, I have to use a logarithm. That's like kind of the whole purpose of a logarithm, is to, figure out what type of exponent I need. So I'm going to take the log with base e of both sides. Now we know that the log with base e is the natural log. Okay, so I'm going to say natural log of e to the x is equal to natural log of 10. But the natural log of e to the x is just the exponent I would put on e to get e to the x. That would be the x exponent. So x is equal to the natural log of 10. This is an exact answer. But maybe I wanted to get an approximate answer. I needed both for like a quiz or something. And so what I'm going to do is I'm going to go in here and I'm just going to type in the natural log of 10. And I'm going to get 2.3026. I believe that it tells you to round to 4 decimals on the quiz, so that's what I'm going to do in this video. So it's 23026. Okay. For the one on the right, I'm going to need to undo natural log, and so that'll be take e to both sides power. And so I'm going to take e to both sides power. E to the log x equals e to the 5. Okay, e to the natural log x, that's just x. X equals e to the 5. Again, e to the 5, this is an exact answer. Okay. But, maybe you also want an approximate answer. Or maybe you're, doing multiple choice and your answer choices are all decimals. Different scenarios call for different answers. Okay, so that's e to the 5 is 148. Again. So that's 148.4132. Okay, and these are our approximate. Okay, so I'm just saying that the exact value has got a log or an e to something in it, whereas an approximate answer is a decimal. All right. Here's another example from your note packet. And a lot of these that I'm not going to do in this video, I'll do at the beginning of the next class as practice problems before we take the quiz. But, okay, so these, if we saw that, the log base 3 of x was equal to the log base 3 of 4, we could confidently say that x was 4. But I've got this 2 here that I need to deal with. It's like, what am I going to do with this? I'm going to use one of my log properties. I'm going to kick that up as an exponent. And I'm going to say that the log with base 3 and argument x squared is equal to the log with base 3 and argument 4. And if these two things are equal to each other, I don't think it's too much for me to say that x squared is going to need to equal 4. So when I take the square root of both sides, I need to remember the plus or minus. Okay, so this is x equals 2, or maybe x equals negative 2. Okay, but when this happens, you need to check your answers, because there's a chance that it could be an apparent solution, but then when you go back in, it's not going to work. And I'm going to just tell you that x equals negative 2 is not going to be a good solution, because when I plug it in for x, I'm going to be taking the log with base 3 and argument negative 2. And there isn't any exponent I can put on 3 to get negative 2. There isn't any exponent I can put on 3 and get anything besides a positive number. That's why, the log of 0 is undefined, why the log of negative 1 is undefined, that type of thing. Because I'm taking a positive number to various powers, and none of those powers are going to result in that positive number becoming negative. Okay, now I'm going to mix in some ones with a few extra steps. And remember that, if all things else equal, when I'm solving an equation, I'm going backwards on the order of operations. Uh-oh, I'm grabbed and drugged. I wanted to draw an arrow. I'm going backwards. So I need to deal with the addition and subtraction first. I need to subtract 3 from both sides. So 4 times 2 to the x is equal to 5. Then I need to deal with multiplication and division. So that's 2 to the x equals 5/4. And now to get rid of the 2 to the x, I'm going to need to take the log base 2 of both sides. I know that these are going to cancel each other out, so I've got x equals the log with base 2 and argument 5/4. Okay, this is the type of thing that we can find in our calculator, but if we need an exact answer, we need to stop right here. Okay, and it would still be an exact answer if you said the log with base 2 and argument 1.25. Okay, but if we need an approximate answer, we'll kind of bring this thing in, and we'll do set up for a fraction. We'll do natural log of 5/4 divided by the natural log of 2. And that'll get 0.3219. And that's an approximate answer. Okay, so, remember exact versus approximate. And another one with, kind of some extra steps in it is one with kind of a more complex exponent. Okay, but we're going to start the same way. I've got the exponential object isolated already. If I didn't, I'd need to do some algebra to, get that thing isolated. So now I'm ready to take a log of both sides. So I'm going to take a log with base 3 of both sides. Take the log with base 3 of 3 to the 4x minus 4. And that will be equal to the log with base 3 and argument 2. Okay. I know that, from the fundamental identity, this is going to be equal to 4x minus 4. And that will be log base 3 of 2. I'm going to add 4 to both sides. And outside the log, right? And then I'm going to divide by 4. And so x equals 1/4 of log base 3 of 2, and then add 4. This is an exact solution. It's got the log in it. We didn't go to the calculator and get a decimal. Okay. Should we need an approximate answer, we can go to the calculator and we can I'm not even going to bring it in, but actually, I guess I will. It's got a pretty weird looking thing, so I'm going to just do that real quick. And what I would recommend doing is just write it exactly like you see it on your sheet of paper. Okay, so a fourth of, okay, well, I know that log base 3 of 2, I'm going to need to, write in a fraction bar and say natural log of 2 divided by natural log of 3. Where is it? There it is. Plus 4. I'm going to get 1.1577. And that would serve as an approximate answer. All right, and the last one I got for you is another one with a given natural log. And the reason I put it in here is that, I think there wasn't one like this in the packet. It was more like, okay, we're going to need to do some steps before we do the exponential or log thing to both sides. Okay, so the first thing we're going to need to do is we're going to need to subtract 2. Okay, so I'm going to say that 3 times the natural log of 5 minus x is equal to -1. Then I'm going to divide by 3. And I'll say the natural log of 5 minus x equals -1/3. And now that I've got the log isolated, I'm going to take e to both sides power. So I'll say e to the natural log of 5 minus x equals e to the -1/3. And so this is 5 minus x equals e to the -1/3. And now I'm going to, subtract 5 from both sides. -x equals maybe -5 plus e to the -1/3. And then I need to divide by -1 or multiply both sides by -1, however you want to say it. And so x would be, I'm going to need to switch the signs of both of these things because distribute the negative to both terms. It's going to be 5 minus e to the -1/3. This is an exact solution. Okay. Should you need an approximate solution, you can over here to your calculator and say 5 minus e to the -1/3. And 4.2835. Which is our approximate solution. I think that's all I got for you. We got a bunch of practice problems on this, and this is the type of thing that I think that y'all should be all right with. It doesn't actually require too much knowledge of the log properties and all this different stuff. It's mostly, can you solve the equation, and especially if you're familiar with, the exact form of the answer, it should be all right for y'all.